All right, AP Calculus AB. It is Monday, April 3rd. All right, and we're doing 8.1. Finding the average value of a function on an interval. That's so fun. All right, mean value theorem for integrals. I've never really used this one for anything. I think this might be one of those theorems that's more important to like prove another theorem, right? Like some are like really important, but you never use them. They're just really important because you use them to prove something else. Okay. So yeah, mean value theorem for integrals. So if f is continuous, there's this number c. Okay. So what this is saying, yeah. So this is saying that like we have a continuous function right here, right? See, it's continuous. Look, it's continuous. Okay. So what it's saying is there's some value between 0 and 8. You see 0 to 8. Y goes from 0 to 8. There's some number between 0 and 8 such that the integral of this function from 0 to 4 is the same as just a rectangle with the same width and the height of that number. No, do you understand what I just said? Okay. So what this theorem is saying is, okay, since this function right here is continuous, okay, since this function is continuous, there exists some y value between 0 and 8 such that the rectangle with the same height as that y value has the same area as this integral right here. Is that better? Okay. It's hard. It's tough. Right, so that's what that says. That number exists. Okay. There's some rectangle whose height is between 0 and 8 and whose width is 4 with the same area as the integral of this function from 0 to 4. Okay. I'm not going to say it again. Cool stuff. All right. Yeah. Yeah, there's some rectangle with the same area as this. Right? Moreover, that rectangle's height is between 0 and 8. That's like the meat of that theorem. The height is between 0 and 8. Okay? So that's going to be used to prove, this is important. This is a pink sheeter. This is a pink sheeter. The average value formula. It's actually very intuitive. Okay? All right? So if I have the numbers 7, 11, 12, someone give me another number. 13, 7, 16, 26, 32.
Who's going to say that?
4.
69.
That's like so confusing.
All right. How would I find the average value of all these numbers? Yes, add them up and divide by the number of them, right? That's exactly what this theorem is, okay? You're adding up all the values of f of x with this integral, and you're dividing by the number of values. Okay, it's the exact same thing. It's literally just the arithmetic mean on a continuous set of values. All right. All right, so how do we do A here? It says use your calculator too. Where's Terry? I had him in my pocket. It says use your calculator. Let's do this. Let's do practice. That's too bad. Yeah, top left has extra. The top left row has extra. All right, so what we're going to do here, right, is find the average value of this function on this interval, right? We're going to do the integral of that function from 2 to 5. Okay, and then we're going to multiply by 1 over 5 minus 2. Okay. This becomes 1/3 times the integral from 2 to 5. Okay. So I'm going to do that on my calculator, okay? you guys recall, right, the best way to do these, the best way to do this on your calculator is to plug in the function into y1. Okay, go back to the main screen. How do I get that integral symbol to pop up again? Math, fn, right? Okay, and then how do I get y1 to be plugged in there? What do I do? What button do I press?
Alpha
Alpha F4, does that work?
Yeah.
Oh wow, it does. That's one thing, or you can just hit the bar key. So that should be your answer, 0.006. Hey guys, make sure, so on the tests, I had to take some points off for people, which stinks. And I can take them off because people didn't round to 3 decimal places. 3 decimal places, 3 decimal places, 3 decimal places, okay? Okay. Okay, now they want find to c such that the average value of f of x is equal to f of c. How do we do that? How do we do that? Scary words, scary, confusing words. Find a number c such that the average value of f of x is equal to f of c. You go a little backwards, yeah? So we have the average value of f of x, right? The average value of f of x is what we just found, right? Okay. So we want to find some f of c. It's going to be 2c e to the negative c squared. We want that to be equal to 0.006. How do you solve that? No. You can't solve it analytically. I'm trying to figure out how to do it. Good question. Can be solved analytically, can be solved with a calculator. What's the x equal? So you can't solve this by hand. I'm going to come back to it later. Oh, I got it. I did it? No, I didn't. I'm not going to do that. All right, we'll come back to that. All right, example 2. Find the average value of this function on this interval. So this is just like plug and chug, guys, okay? So it's just the integral of f of x from 1 to 4 times 1 over 4 minus 1. Okay. Questions, comments, concerns? Yep. Yeah, if you know how to do this by hand, just make sure you know how to do it by hand. Use the fundamental theorem of calculus. Yeah. But yeah, then you can also do it with your calculator, which I'm going to do because I don't feel like doing 4 cubed in my head right now. Four minus the 1, the top minus the bottom. Same way we just did the last time. freaking n. Okay.
Whoa, baby, you can't say that.
I said that. Frack.
Equals what,
16. Okay. Find the values of c guaranteed by the mean value of theorem for integrals for the above function on its given intervals. Sweet. Whoa. Okay. How'd I get what?
How did you get the? You just
Zoom in.
okay.
So let's think about how to do this next one. Let's think about how to do this next one, okay? Find the value of c guaranteed by the mean value theorem for integrals for the above function on its given integral. So what this is saying is there's some rectangle whose width is going to be 4 minus 1. The height's going to be f of c. Okay? That rectangle's area is going to be equal to the integral from 1 to 4. Okay. So 3 times f of c equals 48, or f of c equals 16. So there's some number c, such that when you plug it into the function, you get the average value. They want you to find that c. Okay. What is f of c? It'd be 3c squared minus 2c equals 16. What? 48 is equal to the area, the integral area. The 16 was the average value. The integral was 48 when we divided it by that 3. Remember, there's that 1 over b minus a in front. Get 16. So 3c squared minus 2c minus 16 equals 0. I hate factoring. Is that factorable? 4 minus 4 times 3 times that is 16. Oh, I hate that. So C plus minus 3 times 1, 4 times 4, 1 times 16.
It's 8/3.
8/3. And wait. Oh, okay. So 3c minus 8. C plus 2. Okay, yeah, so we get c equals -2 and c equals 8/3. Thank you, Dinar. Okay, which one of these answers is wrong?
-2.
Why is that wrong?
Because that's
It's not in the interval. Good job. What's up, Andrew?
So when you got the 3c squared minus 2c, that's like the original.
That's the equation, yeah.
You don't have to do the interval of that. I mean the original equation.
Yeah. Yep.
Why do the original and not the x cubed minus x squared?
So, do you see how I got to here? F of c equals 16. So, what this is saying, what the theorem says, that green, this is the green box up here. What it says is when you find the average value, we got 16, right? It doesn't say anything about the integral of the function. It just says there's some number in this interval that when you plug it into the original function, it equals 16. Okay? So the theorem just says when you find the average value, there's some c that when you plug it into f, you get that number. So we want to set the function equal to 16, not the antiderivative. Okay, so that theorem's related to integrals, but to use it in this context. We did all the integral stuff, Andrew. We did all the antiderivative stuff to get to 16. We don't do it for the other side of the equation. Okay. Right. So we use this theorem. The left side gave us 16. Okay. At that point, the right side doesn't even have an integral in it at all. So that's why we use the original function. Okay. That helps. All right, example 3. Got milk? Do you possess milk? Okay, this looks like a good one. It's a calculator problem, which is fun. I love my calculator. I use Brooks' desk. All right, so the cows on a small dairy farm in northern Indiana, Fair Oaks Farms. Anyone ever been to Fair Oaks Farms? You ever been to Fair Oaks Farms? We should do a field trip there.
Yes.
That'd be awesome, actually. I can drive us up there
Yes.
in like one of like the little like shuttles.
Yes.
Are you shuttle certified?
Me and Mr. Shaddy, I could get. I should get shuttle certified.
Mr. Shaddy, I'm glad.
I almost got my CDL in college. My manager forgot to turn in my paperwork to the BMV.
What?
I know. All right, so the cows get milked in the morning. Milk from the cows is pumped to a storage tank. Okay. Estimate m prime of 70. Indicate the units of measure and explain the meaning of your answer in the context of this problem. It's a great review problem. All right, how do we estimate m prime of 70?
Oh.
Estimate. They want you to estimate a derivative. What do you do when they want you to estimate a derivative?
Left relation on stuff.
Left? No, you don't want to do left
Right.
on
You
some.
just go in between.
A lot easier than that. It's a slope formula.
Oh.
It's a slope formula, okay?
Yeah. Oh.
Anyone's have extended family that owns a dairy farm?
Do you?
I will neither confirm nor deny. But if I'm being honest, I will deny. I wish I did. My third cousins used to have a farm up in Wisconsin, but they sold it
Why?
because they got divorced.
Oh. That's it.
No. All right, 43. M prime of 70. So that's about 43, okay? And then what are my units of measure going to be?
Gallons.
Not gallons.
Gallons over minutes.
So M is in gallons. M prime is going to be gallons per minute. So at time, okay, 70 minutes, milk from the tank, or milk flows into the tank at about 43 gallons per minute. Yeah, it's a lot of milk.
How small is this dairy farm? It says a small dairy farm.
It's a small dairy farm. 43 gallons, that's not enough to like make a living.
Well, per minute.
That's not enough to like have a large company, like fund a large company.
20 per.
You gotta think transportation costs. You gotta pay for health insurance for your employees. I mean, it adds up. Adds up. You gotta pay an accounting firm to do your accounting for you, or you gotta pay someone. You gotta hire a CPA. All right. Use the data in the table to evaluate m prime of t dt. Using correct units, interpret the meaning of m prime of t dt in the context of the problem. Yeah, I think you would actually. Let me look at the theorem. So you don't do slope, sorry. It's actually pretty simple. How do you take this? How do you take this antiderivative? What's the antiderivative of m prime of t?
Just
Just m, right? And when we take when we do integrals, we take the antiderivative, right? And then we plug in the top and bottom numbers.
Wait, why are we using
What's that?
Why are we using LT?
So right, so the fundamental theorem of calculus tells us that we can do a definite integral by taking the antiderivative of the integral and then plugging in the top and bottom numbers, right, and subtracting them. Yeah. So the antiderivative of m prime is just m. Then,
What?
you have a question? So m of 20 is, or 120 is 4250 minus 300. You start off with 300 gallons. So what is that, 3950? Okay. How are we feeling about that? Feeling okay? All right, can we do C? Use a right Riemann sum with 4 subintervals to estimate that exact, not that exact same. We want to estimate the integral of m using a right Riemann sum. Okay? How do I do that?
Go from the right.
So I'm going to have 4 intervals, right? 4 rectangles. So I'm going to have 4 rectangles.
Yeah, I already did that.
I'm going to have 4 rectangles. What's the width of all my rectangles? Actually, they're going to have different widths. Let's look at that first rectangle. What's its width going to be? 20.
Wait, isn't that left?
The width does not depend on left or right. What's the height going to be? Since it's a right Riemann sum. What's the height? Oh. Here we go. With the second rectangle, 30, height 1640, okay? Third one, what's the width? 40. 60. $30 and 42. Okay. Now, instead of like plugging this on your calculator, just do 780 times 20 plus 1640 times 30 plus 40 times 3360 plus 30 times 4250. This is a better idea to leave it like this than to try to plug it into your calculator, because a lot of us lost points on the last test because we just made calculation errors. If you had just left it like this, you would have gotten the right answer. Just leave it like that. Yeah. You've all taken that, yeah. What's that? Yeah, I can see it.
Yeah, you're right. Probably not.
Okay. So, and then will this be an over approximation or an under approximation? How do we know it's going to be an over? No, that's not good reasoning. That's not enough. That's on the right track.
Because it goes, it's over, it like goes farther, because you're using the bigger one instead of the small one.
The thing that's
So, it's an over approximation. overestimate, and that's because the function, I think here, what were you saying?
Like, in each like grouping, the four sub-intervals, the number on the right for the y value is bigger than the y.
Yeah, it's an overestimate since the function is increasing on the end. So yeah, to Andrew's point, right? When you've got an increasing function, you're absolutely correct, right? The right Riemann sum overestimates. Right? But when you've got a decreasing function, the right Riemann sum underestimates. Okay? Just be careful there. You see that? We're doing the right Riemann sum, right? There's little gaps here. Just be careful. So it's going to be an overestimate because right Riemann sums are an over approximation, but only on increasing functions.
So you don't have to explain that on increasing they're over. Like they do have to just assume that they know that increased function.
All right. You guys want to? I think everyone's taking the test, right?
Wait, that's not the opposite.
What?
Because that one's decreasing, but over
The right Riemann sum's an under. That's a right Riemann sum. The right corner is touching.
Looking at the chart.
Yeah, the right corner is touching. Yeah.
Wait, which one's right and which one's left?
They're both right Riemann sums. Those are both. Look, the right corner, the top right corner is touching the graph.
Wait, we get to see your test.
Yeah. Do you want to? Pretty well, adverb. No, good job. You did.
I just wanted to keep my head.
We did all take it. Okay, good. All right, so yeah, we got through 8.1. We'll move on to 8.2 after you guys see your tests. Yeah, we're behind. We got 24 minutes. All right, so a little break to see your tests. What are they? Oh, it's an even 7 exam.
How much budget do you have in class?
What?
Class, you have budget out.
Yeah, that's why I put it there. I wasn't just going down the list and clicking that like auto comment.
There's an auto comment.
Yeah.
Dude, Power School is.
And you have to leave a comment. You're supposed to leave a comment, so I just go down the list. Plus, I'm a programmer.
You should write like a whole essay about each one.
That'd be hilarious, like a ballad.
One teacher did.
Like a sonnet. Like I asked him to
Ask ChatGPT to write like.
That'd be hilarious. Alright, so you guys don't get to keep these, sorry.
I don't want to keep that. I want to
Well, I
learn
think
it.
it's which version?
Well,
is
I
this?
don't
Wait, this is the. This is like graphic. Oh, is this the cap? This? Yeah, cap. Okay, yeah.
Rich, what you get?
This one I got.
So what?
Overall, I got a C+.
Alright, that's like the.
Let me see if I can find the key.
This part?
I'm like low key for the prayers, like that happened. I'm like low key. I forgot when I showed up and he was sick, and I was like, just chatting, I need to talk to Mr. Rushkin. And he's like, he'll probably be back tomorrow. Just come tomorrow. So I come in tomorrow, I'm like, Mr. Shady, where's Mr. Rushkin? I need to talk to him about that and stuff. He's like, oh, he'll be back tomorrow. Just come tomorrow. So like, it comes to the last day, and I'm like, Mr. Shady, Mr. Rushkin, I need to talk to him. He's like, no, you gotta take the test.
I was so sick. My mom had to go to the ER. I had to call 911.
Oh,
It was bad.
Why, dude?
Because she got like extremely dehydrated. She couldn't get up.
Did you like carry her and then drive her?
No, I could not carry her. Took her to the
Ambulances
floor
are
and
so
then carried her
expensive.
out. What's that?
Ambulances
I
are
know. She
crazy.
didn't get charged for it for some reason.
She didn't get charged for it?
I don't know why.
What?
Insurance company.
It's like a free taxi ride.
It is bad. I'm actually really concerned about that.
When did she pass out?
Yeah, she passed out.
I must take it.
I got this one. The other part was
I just circled the ones that.
What?
It's still
No, she just got really sick from the stomach.
Dude, I got two.
She got super dehydrated. She went into like some sort of like shock too.
I went 2 for 5 on my guesses. That's not that bad.
Blood pressure got really low.
Are you serious?
I got all of them right.
I'll take a 40. That's crazy.
40% is higher than the base 25%. I'll take it.
I take a little look.
I'll so take it.
Yeah, what's up? Oh yeah, what was the one?
We must have failed the line measurement part miserably. So we missed 2 points on this part.
Yeah. Particular solution.
I got zero. I got
Separation of
0
the
points
right?
off for
Study.
question.
1 for 90, 3 for 9 on this one.
0 out of 2.
I went 3
Yeah,
for
no,
5.
you get it.
Like,
Like,
this is 4 out of 2.
Yeah, like I got. I got.
I got a point off for not putting it negative.
When we turned it in, we thought it was going to be like 30s.
This one?
Hey, if I get somebody who does the type of like
Zero points off for that.
let's do it again.
Oh, is it not supposed to? I knew this part. I didn't know like.
Hey, why'd you get it? Hey, what'd you get overall? What'd you get overall?
Overall.
Yeah.
I think it was like.
I don't know how.
I had a lot of educated guys.
Take a square root of like how many is why you learn.
Mr. Rushka, I have a question. I got a question, Mr. Rushka. So, how is it that both me and Campbell left this one blank, and yet you gave him a point for it?
He did the work by
What? Wait, what?
No,
That's
take-
crazy.
take the vote.
That's
Take the vote.
crazy. Come on.
Well, yeah,
Separate question.
a bunch of people did like the work for that one, like right away.
I didn't know what to do for that one. I thought that was for that one. But that might be why I didn't get that.
Yeah, no, you were doing that. You were doing this problem.
I thought I was doing that one.
Alright, a couple more minutes. So,
That's where you're at.
Oh, 5. Oh, yeah, I was just passing that C. No, that's right, but step 3 is wrong because you really try. It would be best to try this.
Wait, that's our Amy test. Aren't the seniors just done?
spending that week together.
What are you guys gonna do?
We have to do stuff. Yeah, we do.
Smash goes right down.
We have to do stuff.
You gotta actually play that.
We'll teach you, it'll be fun, man.
Will you just teach me like basic algebra?
I'll give you a tutorial.
No way.
One-on-one tutorial with Mr. Rush.
It was alright.
We'll do epsilon delta proofs. That's what I'm gonna do. I'm just gonna go rogue. Like Mr. Shadio, we're doing epsilon delta over here. Really?
I'm putting it in.
Who are you with?
So weird. Admissions don't move. Yeah, it's not
I
like
did not make it.
no one's gone there since my year.
No, we made a mistake.
More than that. Me and Angela to win. The last people who win there.
Top
And
25.
Caroline Press. Who's your butt?
I got.
I think my friends.
You guys want to hear a funny story? Wait, never mind. It's a little embarrassing.
No, you can't just stop right there.
I can't name drop someone. Since I name dropped, I can't tell that. All right, let's pass them up.
Just like say a fake name. Just like
There's this girl Jane Doe.
I know her.
Yeah, I know.
What if your name was actually Jen? That'd be horrible. You'd be like, ho 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 ho.
Oh. I'm just like trying it out.
Dude, when I I met a like US Olympic like skier. She's like 18. He like goes to national championships. He has like a house in Michigan, like on the middle of a mountain. Where he just goes and skis here.
Any others? Alright, let's move on to the next set of notes. Before I forget, pass up the skill builder.
What is what?
Coach Peterson just got back from
I got some color.
Alright, so let's do that for tomorrow, guys. Let's move on to the 8.2.
You're not compared to like other college students.
I looked at the high school highlights. I'm literally better.
Can't believe.
Walk on it.
No,
I'm burning my phone.
Walk on.
That'd be crazy.
Walk on.
It's just what I'm gonna do.
Walk on defense.
well, that's what
I burned out my calculus homework.
I'm trying to
So Mr. Shaddy came to my graduation.
Wait, do teachers like go to open houses?
I couldn't find anything about the Hunter. This is from Australia.
So he's crazy.
I started on it.
What year is he?
That's my house.
I'll be watching DC, so
Wait, what?
I'll be watching DC.
Wait, wait, Ew, nice. That's awesome. Bison.
Yeah, right.
Alright, we go. Okay, now we're doing position, velocity, and acceleration. What's that? Yeah, we're doing it. Alright.
How many units do you have left?
How many units?
Yeah,
This is
like,
the last one.
this is the last one.
Oh, no.
There's only 8-1 and 8-2.
No. The whole chapter. Look through the notes, man. Goes to 8:12.
That's like not my time.
Alright, so teacher moves along a straight line. Okay.
I didn't know this was only chapter 8.
So how far was your teacher's ending position from his starting position? Okay. So where's the starting position? That's going to be 2. The ending is 18. Yeah, it seems 16. 18 minus 2 equals 16. Actually, just leave it as 18 minus 2 in case you make a mistake. We'll like that. 18 minus 2 carpet squares. Oh, I love carpet squares. I used to go to story time at the library when I was little. I had to grab a carpet square.
What?
I went to story time at the library growing up. I remember every time they'd be like, "Hey, everybody, grab a carpet square."
Oh, those things.
It's story
Which
time.
library? Which library?
The White River Public Library, down in Center Grove.
Oh, so not the one.
It's a carpet square.
No, I'm from the south side.
Oh.
All right, distance or teacher travel. Wait, what's the distance or teacher travel? That's a good one.
16.
No.
4, 2, 6, 8.
So my guy, he went from 2 to -2. He went left 4, and then he went right 2, right another 2, and then right 16. So he traveled 4, then he traveled traveled 4, then he traveled 2, then he traveled another 2, then he traveled another 16. Right. This answer key says 26. What? You're wrong. Someone tell me what I did wrong. 4. Oh wait. Oh no, I computed this as 24 in my head. Good thing I just left my answer like that. This is 26.
That's 24.
You trying to like just gaslight?
Wait.
He's just gaslighting that they do 4 plus 2 plus 2 plus 2.
Wait, what? I just got it in my head though. I just got it to work. 4,
How's it plus 18?
2, and another 2. Am I crazy?
No. The answer he's wrong.
I think
Is
it
the
should
answer
be like
wrong?
Yes.
just leave it as 4 plus 2 plus 2 plus 16.
Yeah, this is like that 4 function.
I can't believe we just got gaslit.
This guy gas.
This guy gaslit.
He changed math for us.
Just leave it. Yeah, leave it. Just don't put it. Yeah, just leave it as a 4 function. Okay, just leave it there. Let the grader do that work for you. Okay. All right, example 1: particle motion with technology. Okay. So particle moves along a horizontal line. Okay, the velocity is given by this function. Position is given by s of t. It starts at -3. Okay. So find all the values of t in the interval for which the speed of the particle is 5. How do I do that? What is speed?
Velocity.
No. Close though. What's the relationship between velocity and speed?
Absolute value.
Yeah. So speed is the absolute value. Okay. And we want to know when that equals what? 5. For t's between 4 and 7. Just for t's between 4 and 7. Okay. Best way to do this? Yeah. So I can't remember how to use the numerical solver off the top of my head, so let's just do this graphically.
I'm so confused.
You are?
Yeah.
Okay. What confuses you?
I don't understand for which the speed of the particle is 5. Like, how do you?
So
How is what you set up going to give you?
we wrote down the speed, right? We wrote down the speed, and we set the speed equal to 5. And then we're going to solve for t. They want to know when the speed is equal to 5.
And we're giving
When means you're solving for t.
Is it going to be one? There's going to be one time, or could it be multiple?
Could be multiple, but you only want the t values between 4 and 7.
So what are we graphing?
Yeah, let's solve it graphically. So I got, here's how I'm going to do it. I got the function, right, on y1. y2, I'm going to make the absolute value. I'm going to make that the absolute value of y1. All right, and I want to know when that equals 5. So I'm going to turn off y1 because I don't want to waste my time. And I'm going to see when that red line and the black line meet between 4 and 7. So x min is 4, x max is 7. All right, this is a little extra, so I want to make my window a little smaller. All right, did I do something wrong?
Did we ever meet?
Yeah, so that says no, that'd be no solutions, right? But, where are you wrong? T minus 3, and then t plus 2 plus 2t sine x squared over 12. Oh, I'm in the wrong mode. Sorry. I need to be in radian mode. There you go. There you go. Oh, nice.
I have to be a radiant.
Always be in radian mode. Always be in radian mode. After geometry and pre-cal, we never use degrees ever again. So my two answers here are going to be when they intersect. There you go. 5.621. The first one, second one is 6.520. There you go. So then for part B, what are we going to do? How do we find S of t from the velocity? So S of t, that's just going to be the integral of the velocity. So v of, I'm going to use a dummy variable called t1. Okay. You put the initial value on the bottom. Right? Wait. Do I put the initial x on the bottom? Yeah, I did. Right? Initial x on the bottom. Okay, and then I'm going to add that initial value. Okay, so that's how you find the position from the velocity. Okay.
Wait, average? Oh.
Yeah, so and that was because s of 0 equals -3. So that initial x, the initial x they gave you goes on the bottom of the integral. The top just gets a t, and then that initial y value goes outside the integral. Okay. That makes any sense?
So that minus 3.
So that equation you just did is to give the position, because the position is the same thing as the integral of velocity.
Yeah. Yep. Yep, so the position is the antiderivative of velocity, right? That's because velocity is the derivative of position. Okay, and then to take the initial value they give us into account, we put the initial x on the bottom of the integral. The initial y is just added to the integral. Okay.
Does that mean you're pretty good?
No, it's not. It does not have dt1. This is good notation because like this little thing here specifies what all's in the integral. Yeah. All right, and then use that expression to find the position of the particle at time t equals 3. So then s of 3, that's going to be the integral from 0 to 3 of v of t dt minus 3. Okay, so doing that in your calculator.
Are you plugging in?
Why am I plugging in 3?
Yeah.
Because they say use this expression to find the position of the particle at time t equals 3. So they want you to find s of 3. So in my calculator, remember I have the original velocity function on my y1 line. So I'm going to do the integral from 0 to 3 of y1 minus 3.
What's y1?
Y1 is that function they gave me, v of t. So it's just a function. So negative 6.263. And that's in what, meters per second? What do they give it to you then? They don't give you. They don't give you. They don't give you one. So. All right, we'll stop there. Good work today. Do 8.1 for tomorrow, please. Good work today. Yeah, so